The star Betelgeuse, a red supergiant found in the constellation Orion, has long fascinated stargazers and space experts due to its sheer size and brightness. If Betelgeuse were placed where our Sun is, it would extend out to the orbit of Jupiter, affirming its colossal size. Despite being about 642 light-years away from Earth, its massive size makes it one of the brightest stars visible to the naked eye. However, recently, Betelgeuse has exhibited unusual behavior, such as surprising dimming and brightening cycles, which many scientists believe indicate that the star is approaching the end of its life. The renowned physicist Brian Cox recently made a significant statement that Betelgeuse is on the verge of a catastrophic explosion, expected to occur within the next 2 weeks. This event, known as a supernova, will mark the end of Betelgeuse's life. Yet it will provide a remarkable opportunity for scientists to study one of the most magnificent and powerful phenomena in the universe. As a red supergiant, Betelgeuse is categorized as one of the largest and most formidable types of stars. It has been on the astronomical radar for a long time, but its recent unusual fluctuations in brightness have sparked theories that it is preparing for a supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, leading to a massive explosion that releases an enormous amount of energy, radiation, and stellar material into space. Betelgeuse's impending explosion is anticipated to be a Type II supernova, a specific kind of stellar explosion that occurs when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shock wave that tears the star apart. The explosion will be so bright that it may be visible from Earth without telescopes, potentially even outshining the moon in the night sky for weeks or months. While such an event would typically be devastating if it occurred near Earth, Betelgeuse's distance of about 642 light-years means that, although the explosion will be visible and dramatic, it will not pose any danger to life on our planet. Nonetheless, the event promises to reshape our understanding of supernovae and cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will emit throughout its entire lifetime. Betelgeuse's explosion will not only be a stunning celestial display, but also a significant moment for science. Researchers are eager to observe this rare event from its very beginning, using a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to capture as much data as possible. When Betelgeuse explodes, it will emit a wide range of radiation, from visible light to gamma rays. One of the most crucial aspects of the supernova will be the surge of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion due to their ability to pass through almost everything without being affected. Observatories, such as Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica, are preparing to detect these neutrinos, providing an early advantage in observing Betelgeuse's final moments. The explosion will also offer essential insights into the creation of heavy elements. When stars explode, they produce and disperse elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will give scientists a clearer view of this element formation process, which is crucial for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's supernova is not expected to have harmful effects on Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the emission of cosmic rays and charged particles, could result in more intense auroras, expanding the regions where the northern and southern lights are visible. While these cosmic rays might affect satellite communications and some technology on Earth, the disruptions are expected to be minor and short-lived. One of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. This display will captivate not only the scientific community, but also amateur stargazers and the general public, reigniting interest in astronomy and the universe. Scientists have long speculated about Betelgeuse's demise, but Brian Cox's recent statement adds a sense of urgency. Observatories around the world are preparing to study every phase of the supernova, and the data collected will be crucial, potentially transforming our understanding of stellar evolution, core collapse supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers an unparalleled opportunity to measure how energy from such an explosion travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, astronomers will gain a clearer understanding of the scale of the universe. Specifically, the event will offer a once-in-a-lifetime opportunity to explore dark matter and how it might affect the structure of the universe. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, does not emit or absorb light, making it hard to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to understanding the life cycle of stars, particularly how massive stars contribute to the formation of the elements essential for life. Supernovae are the primary cosmic events responsible for spreading heavy elements throughout the universe, elements that ultimately form new stars, planets, and even living things. By studying Betelgeuse, scientists will gain valuable insights into how these elements are created and distributed. The cultural significance of Betelgeuse's explosion is also profound. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the Orion constellation will prompt philosophical reflection on the transient nature of the universe. In some cultures, such celestial events have been interpreted as omens or signs of significant change. Betelgeuse's explosion might evoke a mix of awe, fear, and wonder as people from all walks of life witness the death of a star. This grand event is likely to inspire renewed interest in space exploration and astronomy, drawing more people into the pursuit of knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows almost anyone with a camera or telescope to observe and record the supernova. This democratization of science will unite people across the globe, all watching and documenting the same cosmic phenomenon. Peculiarity from their exceptional vantage focuses. Betelgeuse's blast isn't simply an explicit cosmic occasion, yet additionally a venturing stone for future investigation. The information got from the cosmic explosion will illuminate how we concentrate on different stars, particularly as we adventure further into space with missions to different planets and stars. Understanding the life patterns of stars and the properties of supernovae is urgent as mankind hopes to grow its presence in the nearby planet group and beyond. Besides, the blast will reignite interest in the quest for extraterrestrial life. Supernovae are fundamental for scattering the components expected for life, like carbon and oxygen, across the universe. By contemplating Betelgeuse's blast, scientists can better figure out how the structure blocks of life could spread to other planetary frameworks and possibly spark life somewhere else in the universe. The approaching blast of Betelgeuse is set to be one of the most critical cosmic occasions in late memory. Its cosmic explosion will provide a wealth of logical information, improve our comprehension of the universe, and without a doubt enchant individuals around the world. Betelgeuse's demise will mark the end of a giant star. However, it will likewise represent the ongoing pattern of creation and obliteration that governs the universe, advising us that from death, new stars, planets, and even life itself can emerge. As we plan for this noteworthy occasion, the world will watch the night sky enthusiastically, anticipating the moment when one of the universe's most impressive forces detonates into view. For researchers and stargazers alike, Betelgeuse's conclusive excursion will be a spectacle. moving as Betelgeuse approaches the last phase of its life. One of the more theoretical, yet interesting potential outcomes related to its blast is the possibility to reveal insight into some of the universe's most prominent secrets: dark matter and dark energy. These baffling powers are believed to represent the majority of the universe's mass and energy. However, they remain poorly understood. Some speculate that supernovae like the one anticipated from Betelgeuse could hold the key to unlocking some of these secrets. Supernovae discharge a monstrous amount of energy and radiation, and a few researchers believe these powerful forces may interact with dark matter in ways that we can observe and study. One fascinating hypothesis is that dark matter exists in the form of weakly interacting massive particles, WIMPs. Assuming that WIMPs exist, their interaction with the energy generated by Betelgeuse's cosmic explosion could provide hints to their nature. Such a discovery would be momentous, providing the first direct evidence of dark matter, a tricky peculiarity that has astounded researchers for years. Furthermore, there is the potential for Betelgeuse's blast to shed light on the nature of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. By examining the behavior of light and energy from Betelgeuse's cosmic explosion, researchers could gather essential data about how massive events like supernovae impact the universe's expansion and how they could relate to dark energy. The approaching blast of Betelgeuse offers a unique lens through which to examine the life cycle of gigantic stars, which play a pivotal role in the formation of the universe's large-scale structure. Red supergiants like Betelgeuse are rare in the universe, making their study essential for understanding stellar evolution. These stars form from clouds of gas and dust that collapse under gravity, ultimately igniting nuclear fusion in their cores. As they consume their hydrogen fuel, they expand significantly, shedding their outer layers in a series of intense solar winds. This mass loss contributes to the development of the interstellar medium, setting the stage for new star formation. When Betelgeuse goes supernova, it won't just reveal insights into its own life cycle. It will also act as a significant examination lab for studying the conditions under which stars live and die. Researchers will closely monitor the outcome of the blast, where a neutron star or black hole might form at the center. The nature of this remnant will provide critical insights into the physical processes that govern the final phases of stellar evolution. The elements of the blast itself will also offer an abundance of data. The shock wave created by the cosmic explosion will travel through the surrounding gas and dust, heating it and making it shine brightly. This light will provide astronomers with clues about the elements that were formed during the explosion, including iron, nickel, and other heavy elements. By studying the spectral signatures of these elements, researchers can determine their abundance and distribution, enhancing our understanding of how these elements spread through space and contribute to the formation of future stars and planetary systems. Another area of interest is the potential detection of gravitational waves. As the core collapses and the supernova occurs, it may produce ripples in space-time that can be detected by observatories like LIGO and Virgo. Gravitational waves convey information about the dynamics of the event, potentially offering new insights into the physics of supernovae and black hole formation. Betelgeuse's blast could also act as an impetus for technological advancements in astronomy. The expected surge in observational data will likely push the limits of current astronomical instruments, leading to breakthroughs in imaging technology, data processing, and ongoing research benefiting a wide range of astrophysical inquiries. Beyond the cosmic explosion, public engagement will be a vital aspect of Betelgeuse's supernova, fostering a sense of wonder and curiosity about the universe. Educational programs, outreach initiatives, and citizen science projects can utilize this event to inspire the next generation of astronomers and physicists. Schools and universities may organize viewing gatherings, lectures, and discussions that highlight the importance of understanding the universe and our place within it. As we anticipate this grand event, the excitement resonates through both established researchers and amateur enthusiasts. The hope surrounding Betelgeuse's cosmic explosion epitomizes humanity's desire to explore the unknown, to challenge our understanding of the universe, and to pursue knowledge. The death of a star, in this sense, becomes a powerful reminder of the cycle of creation and destruction that defines the universe, prompting us to reflect on our own existence and the mysteries that lie beyond.